LangGraph implements a stateful, directed workflow through a typed state machine pattern, where nodes perform deterministic transformations on a shared state dictionary. This artifact demonstrates the foundational mechanism of graph construction, node registration, and linear edge routing without introducing streaming or asynchronous patterns. We are about to examine a minimal graph definition that initializes a state schema, registers two transformation functions as nodes, and compiles a sequential execution path from start to end. The code will reveal how state mutations propagate through the node chain, with each function receiving the current state and returning partial updates that merge into the shared context.
From typing import typed dict. From LangGraph, graph import state graph start end. Class state type dict. Topic str. Joke str. Def refine topic state. Return topic statey topic in cats. Def generate joke state. Return joke. F this is a joke about state topic. Graph equals. State graph state. Add node refine topic. Add node generate joke. Add edge start. Refine topic. Add edge refine topic. Generate joke. Add edge generate joke end. Compile.
This code demonstrates a basic LangGraph workflow for building and compiling a stateful graph without streaming. The pattern follows a directed acyclic graph DAG structure, where nodes represent state transformations and edges define execution order. The implementation uses statEgraph to create a graph with two nodes, refine topic and generate joke. Each node is a pure function that takes the current state, modifies it, and returns updates. The graph starts at start, processes through refine topic, first which appends and cats to the topic, then passes to generate joke, which creates a joke string, and finally reaches end. The compile method finalizes the graph structure before execution. This approach provides a clean, declarative way to model state transformations as a pipeline. The separation of concerns between node definitions and graph structure makes the workflow easy to understand and modify. However, this basic implementation lacks error handling and doesn't demonstrate the streaming capabilities that are central to LangGraph's value proposition for real-time applications. The pattern is suitable for simple, linear workflows where each step depends on the previous state transformation. Let's break it down.
From typing import typed dict.
Imports typed dict from the typing module, which enables creating dictionary types with specific key value type annotations for static type checking.
From LangGraph, graph import state graph start end.
Import state graph, start, and end from the LangGraph graph module. StateGraph is a class for defining stateful workflows, while start and end are constants representing the entry and exit points of a graph.
Class state type dict
defines a state class that inherits from typed dict, indicating it will be a dictionary-like structure with type annotations for its keys. This establishes a type dictionary for state management, where each key-value pair will have explicitly declared types to enforce type safety and provide better IDE support.
Def refine topic state
defines a function named refine topic that takes a single parameter, state, with type annotation state. The function is declared, but its implementation isn't shown in this segment.
Return topic, statey topic, in cats.
Returns a dictionary with a topic key, whose value is the current state's topic value concatenated with the string and cats.
Def generate joke state
defines a function named generate joke that takes a single parameter, state, with type annotation state. The function signature indicates it will operate on or return something related to a state object, though the implementation details aren't visible in this segment.
Return joke. F. This is a joke about state topic.
Returns a dictionary with a single key, joke, whose value is a formatted string that incorporates the topic from the current state. The string template creates a joke about whatever topic is stored in state topic, with the final output being a dictionary like joke. This is a joke about topic, where topic is replaced by the actual value from the state.
State graph state.
Creates a new state graph instance using the provided state class as the state type. This establishes the foundational structure for defining a state machine where nodes represent states and edges represent transitions.
Add node refine topic.
Adds a node named refine topic to the graph. This node will be part of the graph's execution flow, representing a step or operation that processes or transforms data related to topic refinement. The exact behavior of this node depends on how refine topic is defined elsewhere in the code, but this line specifically registers it as a component in the graph structure.
Add node generate joke.
Adds a node named generate joke to the graph. This node will be a callable unit in the workflow, likely representing a function or component that generates jokes when executed.
Add edge start, refine topic.
Adds a directed edge from the start node to the refine topic node in the graph, establishing that the workflow begins by transitioning to the topic refinement step.
Add edge refine topic, generate joke.
Adds a directed edge from the refine topic node to the generate joke node in the graph, establishing that the joke generation step follows topic refinement in the workflow.
Add edge generate joke end.
Adds a directed edge from the generate joke node to the end node in the graph, establishing that after joke generation completes, the workflow should terminate.
Compile.
Triggers compilation of the current graph configuration, validating the structure and preparing it for execution. This method call processes all defined nodes, edges, and workflow logic to create an optimized execution plan. This implementation showcases LangGraph's core pattern of modeling workflows as stateful, directed graphs, where nodes perform deterministic transformations on a shared state dictionary. The state graph orchestrates a linear pipeline through method chaining. Nodes are registered as pure functions that receive and partially update the state, while edges define the execution order from start to end. The typed dict state schema enforces type safety, with each node returning a dictionary that merges into the shared context. This declarative approach cleanly separates node logic from graph structure, making the workflow easy to modify. However, this basic DAG structure lacks error handling and doesn't leverage LangGraph streaming capabilities, making it best suited for simple, linear state transformations where each step depends on the previous output. The key insight is how state mutations propagate through the node chain, with each function's return value merging into the shared state before passing to the next node.
The topic bows to refine topic, which grafts cats onto its spine, while generate joke naps in the void.